Now I am recording. Sorry, hold on. Now I'm recording. These all go
record. Does that record our voices?
Yep. It records everything.
Yeah, we're gonna be on YouTube.
Records everything. It's the best is when I discipline my classes and it goes on YouTube, and you hear me halfway through lesson like, everyone needs to be quiet right now. On blast. You should send it to your parents. Be like, this is what I go through. I'm just kidding. All right. That's proportionate relationships. Okay. Now, this lesson is on, or proportional. This lesson is on using proportional relationships. Okay, so we're going to use proportional relationships. All right, and if we read this first sentence, blank is any method that uses formulas, similar figures, and or proportions to measure an object. What is this? Indirect measurement. So indirect measurement is when you're not just taking a measuring tape or a ruler out and measuring something. Indirect measurement is when you're using some kind of formulas or ratios or relationships to actually measure it. And we see an example of this indirect measurement in the example below. So I'm going to go through this example with you guys. Okay, let's take a look. So here we see we've got a big old pineapple and a little old person, okay? And both of them are casting shadows, you see? So it's like you can imagine the lights here, it's casting a shadow, this is casting a shadow. Well, when it casts shadows, it forms similar triangles, okay? So it forms similar triangles, all right? And since it forms similar triangles, you have proportionate relationships. So what does that mean? Well, the ratio of the shadow to this shadow is equal to the ratio of the height of the pineapple to the height of the girl. Does that make sense? So to kind of bring back my colors, right? If this was blue here, then this would be blue here, right? And if this is red, the height of the girl here, then this would be red here. Does that make sense to you guys? You see that? So what's the ratio? Red over red equals blue over blue. That's my ratio that I set up. And I can use that to solve for, what do you think I'm solving for here, guys? What does it say?
Yeah.
What is the height of the pineapple? So here's the height of the pineapple, which is df. Okay? So the height of the pineapple is df. I'm solving for the height. So if I got to solve for that, I set up my ratios, right? And that's now, before I set up the ratios, what do you notice about these things here? There's feet and inches, right? So what I want to do is convert everything to inches, okay? So I do 8, first instead of 8 feet, I do 8 times 12 to figure out how many inches that is, and I get 96, you see? But then I have to add the 9 inches here, so it's 96 inches plus 9 inches is 105 inches, and that's exactly what they get here. Okay, 2 feet. How many inches is 2 feet? Class? How many inches
24.
in 2 feet? 2 feet is 24 inches. 2 times 12 is 24. So that's exactly what they get here. And then it says the girl, it doesn't show it on the picture, but she's 5 foot 4 inches, so that's 5 times 12 plus 4, or 5 times 12 is 60, plus 4 is 64. So she's 64 inches, and that's exactly what we get. So do you guys understand how to convert from feet and inches to just inches? Okay, so whenever we've got something like that, we just convert it into inches. All right? And then once we have that, we can set up our ratio. So this is 24, and this is 105. This is 64, and h we don't know. So how do they set it up? Well, they say, so let me forget about step 3, just forget about how they do it exactly, and you can write it, because I want to show you how I would do it, and it's less cluttered, okay? So how do we do it? Well, we compare the red to the blue, right? So it's H over How many inches? How tall is the girl?
5, no, like 6.
64, right? So it's red over red equals blue over blue. And the blue on the right is 105. Which one do I put on top? 105 or 24? This is 105 here. This is 24 here. Why do I put 105 on the top?
Oh, never mind, you put 24.
No, that's right. It is 105.
The bigger number.
Because I have to stay with the triangle that I put on the top at first has to stay on top. So look, this triangle here was on top. See, H is on top. So 105 should be on top as well because this triangle is on top. Does that make sense? This shape is on top, so I got to stay consistent with that. If H is on top, then 105 is on top. Does that make sense? Okay. So since that shape is on top, it goes 105 over 24. And what do I do now, class? Cross multiply, sure. What? Nice. So I get 24H equals 105 times 64. And then divide by 24, right? And I get H equals 105 times, let's pay attention, guys. 105 times 64 over 24.
Why don't we just multiply 105 and 64?
What?
Why don't we just multiply 105 and 64?
We did 105 times 64 and then divided it by 24.
That just says times. You didn't actually multiply.
I divided here.
You just wrote it. You didn't actually do it.
He used a calculator.
Oh, okay. Wait. So then it's 280 divided by 24.
No. So I did 105 times 64.
Yeah.
So 105 times 64 is 6720. So it becomes 6720 over 24, which is 280. Does that make sense?
Yeah, I just didn't. Why didn't you write it then?
Just because I skipped a step.
Okay.
Sorry.
You're good.
Okay, so H equals 280. All right? So H is 280, right? But I have to figure out how many feet that is. So what do I do to figure out how many feet that is? Divide by 12. And I get 23.33, right? So H equals 23 feet, but I have to figure out how many inches, right? So in order to do that, I do 23 times 12 is 276. And how many more inches do I have to get to 280? 4. 23 feet, 4 inches.
Wait, did you get 23?
Because I did 280 divided by 12, and I got 23.333, right? Does that make sense? But I have to figure out how many inches it is.
Because you're converting it to feet again.
Yeah, converting it to feet. So I divide by 12, and I get 23.3333. And then I take the leftover, the decimal, which is 0.3333. So 0.3333, and I multiply that by 12. Does that make sense? And that gives me basically 4 inches.
Does it matter how many feet you put?
Not really, it's just gonna make it look better, you see?
Right.
So the more 3s, the more closer it is to 4. But you know that it's 4 because it would be 4, it's just repeating. Does that make sense? So I got 280 divided by 12, I got 23.333. So I know it's 23 feet, but I have to figure out how many inches. So how do I figure out how many inches? I do 0.333 times 12, and I get 4. Is that pretty clear, guys? Okay. What was the biggest thing here? It's not the converting from inches and feet. The biggest thing here is being able to set up the ratios correctly. Any questions on that? Okay. All right. Next is you guys have an example to do, so go ahead and do it.
Can I just get some water real quick?
Yeah, go ahead. It's almost the exact same way. It's almost the exact same problem. So see if you can do that. So what do you do first, guys? Convert everything to inches. And I'm going to do that on the board here so you can kind of just see it after you're done. So I'll just write them what they should be. But don't look at this until you're done now. Don't look at it until you're done because I want you guys to find the answers yourself. Sure. Why don't you just sit over there just so you can open the door for Olivia when she gets back. Just sit over there just for a second until she gets back. Just so you can open the door first, please. Thank you. You guys got it? Working on it? Remember, guys, this is like the gold time. This is the time where it's like your teacher is studying with you. Right? You want to be using this time wisely.
So then we divide it.
You have to set up the right ratio first, and then you divide. Or well, then you have to solve it.
Can you write within your 10? You just multiply it.
I'll have to take a look. Okay, you guys see how this color coding helps?
Yeah. A lot.
All right, so just think about that when you're gonna come up to a test, right, on Tuesday. Man, I should probably bring in some colored pencils. Mark them up. Just do the thing that helps. So h over 66, red over red, equals which one goes on top? 160 or 170 or 60?
170.
Why does 170 go on top?
Wait, did I do the wrong one?
No, because h is on top, right?
But where'd you get 170?
So whatever the
170 inches. You have to convert it to inches first.
That's why, okay. I was wondering why.
Yeah.
Okay.
So 170 over 60, right? Because h is on top, so the right triangle is on top, right? Then there's a couple ways I can do this. The way that I do it is, if I have h on top, I just multiply by 66. You see? I could just multiply both sides by 66, and then that crosses out, and I get that, and I get h equals 170 times 66, which is 11,220 over 60. So h equals, and then I divide that, and I get 187. So is that 187 feet or inches?
Inches?
Inches, that's right. I converted everything to inches. So I'm going to take 187 now, and I'm going to divide it by 12 to get it in terms of feet.
15.58.
Right, so I could say it's 15.583 repeating feet. I could say that, right? But what I'd rather you do is just say it's 15 feet, and then take 0.583 and multiply that by 12, and you get, hey, that's just 7 inches. You see? So 7 inches. So you take whatever the decimal is, you multiply that by 12 to get the number of inches. Does that make sense? You divide by 12 to get feet, but then you take the decimal and multiply that by 12 to get the inches. Yes, sir?
So you 187 multiplied by 12.
I do 187 inches divided by 12, and that's how I get 15.583.
And
Then I take this decimal and multiply it by 12.
So then is it wrong if you don't convert it? Like, because you're,
It's not necessarily wrong, but you'll probably find like on multiple choice, I would accept 15.583.
that's what I got.
Right? I would accept that because technically that's correct. If you didn't put the repeating over the 3, I would dock a point because you're rounding. If I tell you to round, that's one thing. But you understand what I'm saying?
Because I did 5.6 and then I times it by 14.
It shouldn't be 5.6.
Yeah, I just
It's-
realized that.
It's not 5.6. Exactly.
Okay.
Yeah.
I didn't realize that.
Because there's not. If there were 10 inches in a foot, then it would be.
yeah.
Okay. Any questions on that, guys?
You want me to come back, right?
Yeah, please. Thank you, sir.
The 187 you divide by 12. In order to-
And you can sit. You can sit over there if you like, wherever. I just want you up front. All right. Let's continue on. Any questions on this, guys? Let's continue on.
Look, I'll just stay here.
Okay. All right. Next. Okay. A what represents an object as smaller than or larger than its actual size. What this is called a scale drawing. A scale drawing. So what's a scale drawing? A map is a version of a scale drawing. Okay, it's representing something smaller or larger than its original size. So if I have a map of the United States of America and it's this big, that's clearly a much smaller scale than actual size, right? So that's a scale drawing. There's also things like blueprints of a house or of a school, right? If you have the blueprints, it's a floor plan, right? You have the whole school on this piece of paper, right? It's obviously not as big as the whole school. It's a scale drawing. Okay, so that's what a scale drawing is. And then the second part is the drawing's scale is the ratio of any length in the drawing to the corresponding actual length. So if you have a map, right, and like the map is 1 inch is 1 mile, right? Well, the scale is 1 inch to 1 mile. Does that make sense? So if I were to go look on a map and I measure and I see, oh, something is 4 inches away on the map, how many miles away would that be? 4 miles. Does that make sense? So that's how you use this scale. Okay? So you use this scale exactly like you would think, look on Google Maps, right? A good example of that is go on Google Maps, right? And right? Usually they will have scale. Oh yeah, there you go. Look, you see right here? See that scale right there? 200 miles. Now look, you see that distance from here to here is 500 miles. You guys see that? Yeah? So, I could use that, right? For instance, I could figure out, the width of Lake Okeechobee. You guys know Lake Okeechobee?
No. Where is that?
It's
Florida.
it's right
I
here.
was in Okeechobee.
It's right here. So look, if you look at this, you can kind of see, right by the scale, you see I'm dragging Lake Okeechobee? It's right here. It's about 20 miles wide. You see that, guys?
Okeechobee.
About 20 miles wide and maybe 30 miles high or tall. Long. right? Cool. You see, that's a scale. Does that make sense? So I could zoom in more, sure, yeah.
Like, give you like a picture
Of Lake Okeechobee?
They're like satellite.
can you go
Sure.
Can you go
Yeah.
Oh, that looks
There
sad.
you go.
Whoa, it's
cool.
like real life.
Because it is.
It's real life.
You guys want to see one of my favorite parts of the world on Google Maps?
Yeah.
There's two favorite parts.
I always
Real life.
try to search up like alligators or like sharks to see like if they can pop up, like the actual animals, you know?
Oh, is that Canada?
Do they actually show up?
I don't know.
Just that.
It looks like a
Usually they
picture.
don't. But I would
To
search like,
Siberia.
I would search like Shark Valley.
What is that?
Like I can see them in the water.
This is one of my favorite
Are
parts.
those an actual
Alaska?
Isn't that cool?
It showed like this weird.
I just think it's so cool looking. There's that part. You see?
What is this?
Isn't it cool? Kind of looks. This is up north near like North Pole. You see, it's kind of like a tree.
Yeah.
And it also looks like blood vessels.
Yeah.
Isn't that so cool to me? That's just such a beautiful
This is the North
fingerprint of
Pole.
God. No, that's close to the North Pole.
Wait, go to Alaska. Can you go to San
Oh,
Antonio? We can't forget
it's-
Alaska because well,
There's
is
Alaska.
Is it really 500 miles though? Because Alaska's part of America. So
Alaska's
Yeah,
part
I
of the
don't know.
America.
yeah.
I'll show you my other favorite place. This is my other favorite place.
The America. We are the America.
You put respect on its name.
This is my other favorite place.
We're the
Look at that. This is the southern tip of Chile. Look at that.
We still have those Alaskans up there.
Shh.
The US of A.
You guys see this?
Good street view.
Whoa.
Is that an actual
I don't
picture?
think there is street view.
That's the mountains.
Oh my gosh.
I don't think there are any
Where is
streets.
that?
This
Those
is
are
the
clouds,
southern
though.
tip of
That's
Chile.
on planet Earth.
Chile.
Chile.
It's Chile.
Are you from there?
No.
Oh, the way you
Where
pronounced
are you
it.
from?
Chile.
It's because most people say Chile, but it's not Chile.
Wait, can't you
Chile.
can't you go like on roads like?
Mike, what do you know how?
I wish I could, but there are no roads down here.
It's Chile. It's
Oh,
Chile.
right there, isn't there?
It's Chile.
Chile. Chile.
Chile.
Wait, where are you from?
I guess they don't have scouts out
I'm
there.
from here. but my-
You have it on the road.
Wow.
Anyhow.
I say we take the
Whoa,
Wow.
pretty
Let's
go-
cultural.
let's go take a trip.
Yeah.
5 stars.
You are?
4.8.
Close enough. Round it 5.
I wish I could show the things that I want.
You just put the person on the road.
Just Google
There is
the
no
name.
road.
Everyone knows.
Yeah, like that.
They don't Google down there. All right.
What do you mean they just Google down there?
Okay.
I
Shh.
just
shh,
saw the part, name of the park.
Yeah, I know. All right. So that's cool. So that's a scale drawing, and we saw the scale. All right. Now let's take a look at example questions. Okay. I made these example questions to be very similar to your test. Okay. So let's pay attention. Cool. Good. All right. Let's take a look at these because I specifically made all 3 of these example questions to be very similar to test questions. So let's pay attention. A drawing of a patio has the dimensions shown. Here's my patio, here's my drawing. The patio is actually 10 feet wide. What is the length of the patio? So we know that they're similar because it's just a drawing, right? Like I wouldn't draw this extra wide or extra long. No, I would have it the same dimensions, so they're similar, right? So what do? Well, I just do the same kind of thing. It's a rectangle this time, but I compare my red to my red and my blue to my blue. You see? So what am I looking for? I'm looking for x. So x would be x over 7 inches equals the blue, which is
Do you always
10
put the long side on
feet.
top?
over, no, not always. I always put the variable on top because then it makes my algebra easier. Because then I don't have to cross multiply, I just divide, I multiply. All right, so x over 7 equals 10 over 4. And then I just multiply both sides by 7. And I get x equals 10 times 7 is 70 divided by 4. Shh, Olivia, pay attention. 70 divided by 4 is 17.5. So x equals 17.5. Now, is that in inches or feet?
Feet.
Good. 17.5 feet. Now, in this case, what you guys can notice is that I didn't convert, right? Well, when you're having these scale drawings, you don't really want to convert because it's unnecessary. Okay, just keep this one. Look, these are both in feet. Those are both in inches. As long as they're both in inches, and these are both in feet, you're fine. The only time you have to convert, guys, the only time you have to convert is if like this was in feet and this was in inches. Does that make sense? Question?
Oh, so it's fine to leave it like that?
It's fine as long as like on the drawing, and that's how it's always going to be. Like you're not going to say, oh, this is 8 feet on a drawing and this is 3 inches. That wouldn't make sense. You know what I mean? Generally speaking, it's just going to be like, oh.
And how
inches,
come we had to
inches.
convert it for the other one?
Because it's a very good question. Why did we convert it? Why did we convert it for the other one? Because it's easier just to convert everything to get it all in the same units when there's a mixture. Remember, it was in feet and inches, right?
What?
Oh,
Yeah.
feet.
It was in feet and inches. so
Oh
it's
yeah,
like-
because feet and then okay.
Yeah, so we want to convert it because otherwise it gets confusing.
Oh, well, I
Does that make sense? But here it's just like, oh, 4 inches, 7 inches, that's fine.
Hey,
Right?
can you measure root 3, yeah?
We can after class is done, maybe. All right, shh. Now go ahead and do example 2. Guys, do example 2. This one doesn't have a picture, so it's up to you to draw it. Shh.
Mr. Munir?
You've been doing it for 38 minutes.
Mr. Munir? Oh, never mind.
Okay. Example 2, and you guys probably want to draw a picture because there's no picture there for you. Sorry that I didn't leave a lot of space. I didn't mean to.
Oh, yeah.
You can kind of use space on the bottom if you like, or you just use space that you thought.
Okay, so do we convert the
Can I use that ruler real quick?
17.5? You want to use it?
Oh,
Yeah.
sorry. Guys, sorry. On this last one, 17.5 feet, you can leave it there. You can leave it at 17.5 feet because you don't have to round,
It's converted yet.
right?
The sand.
Wait, so why don't we convert it to inches? Or
You could, but you don't have to because it's exact. It's not like 0.583722 whatever,
Right.
but it's just 17.5. There's no problem with that. That's exact. That's an exact answer.
will it always be exact with these?
Not always, but as long as you have an exact answer, then you should. But if you wanted to get it in inches, you just multiply by 12 and you get 6. And so it would be 17 feet, 6 inches. Right? Good question. All right, next one, example 2.
Wait. Oh, okay, never mind.
So example 2.
I thought that was like the answer. I was
No.
like, what?
That was for example 1. So draw your pictures.
Can I use a calculator?
No. You don't need a calculator for this. Come on, Colton. Let's go. Put that
You should put the variable on top.
The variable?
Generally speaking.
What did I say?
Yeah. Generally
What did I
speaking,
say?
I'll put the variable on top of it.
The variable. I said it right.
No, I just didn't
Oh.
know that you were doing stuff with variable.
What?
I didn't understand.
Yeah.
40.
Wait, no.
Yeah, it's like 40.
Could you go back for a minute? I wouldn't
Yeah.
even know down in mine before you over X. It's the same thing. Just same thing. It doesn't matter if you put like 40 over X instead
I
of
got
X
4
over
feet.
40, right?
It has to be.
I got 40.
Make it,
I got 4 feet.
it's still the same thing, but I just like,
As long as you're consistent. You have to be consistent. So if your drawing is on top, it has to be on top of both fractions. If your building is on top, it has to be on top of both fractions. Does that make sense?
Yeah.
Okay.
Is this right?
Matthews, you didn't forget to draw. You weren't focusing. Okay. Let's make sure we focus. I'm telling you guys, these example problems I'm going through right now are very similar to the test. So if you space out now, what do you think is going to happen on the test? It's gonna magically just come into your mind? No, it won't. Well, by the grace of God, it can, but
Grace of God.
God is also a righteous God.
yeah.
And He chastises those
Yo,
who love
where's
us.
the plan?
All right, you guys should be done with this by now. Shh, shh, shh. Guys, there's a little too much talking. A little too much talking. It's the end of the day. All right. So here's our building.
I got
Here-
4.
Here's our building. It's 100 feet wide and 40 feet high. Then we have a picture of the building, and it's 10 inches wide, and I'm figuring out how high it is. Well, here's my red, here's my red, here's my blue, here's my blue. Simple as that. x over 40 equals 10 over 100. Okay, what do? I multiply both sides by 40. And I get x equals 10 times 40 is 400 over 100, or x equals 4. Is that feet or inches?
Inches.
Inches. So
Yeah, I got that.
how high should the building be drawn? 4 inches high. Okay, next example. We got to go faster, guys. What?
How do you determine which measurement you put on?
Because since this was in inches, this has to be in inches.
Okay.
Does that make sense? These are both in feet. These are both in inches.
But the other one before was inches and feet. So how do you determine?
The one before, the one before was technically in feet. It's just you then converted to be inches. Does that make sense? So it was like
Oh,
your
I
answer was
wonder, I thought you had to
17.5
rule it
feet,
out.
not 17.5 inches.
How long? Wait, how should the
Why
building
would
be
you
drawn?
do that?
So since we have to draw inches,
No, how high is the building on the drawing?
no, the building says how should the building be drawn? Drawing the building should be inches.
Yeah.
So you just constantly-
I don't get what's so funny.
It's just shh. It's because this one's in inches. He does it, that's in inches.
So where the variable is.
What's so funny?
I'm laughing because we're laughing.
So whatever
I
this
think
measurement is,
Olivia's laughing because we're laughing.
does that make sense?
Yeah.
Okay.
So where the variable is, that's where the.
Measurement is.
Me?
All right, guys. Marcus,
Yeah.
Colton,
Yes.
Matthews, Olivia,
Yes, sir.
Randy. Let us focus now.
Yes, sir.
A drawing of a stadium uses the scale of 3 inches to 200 feet. Find the width of the stadium if the drawing is 12 inches. Okay, now this one's a little bit different. Okay, what do you do here? Well, if it's 3 inches to 200 feet, your ratio is 3 over 200. Okay? And so this ratio, look, this ratio is set up in a way that it's the drawing. So it's the drawing, I'll put in blue, over the drawing over the actual stadium size. So it's 3 inches over 200 equals, well, the drawing here is 12 inches, and I want to figure out the actual stadium. So I put
Wait.
the.
What did we do? We're not doing the thing?
It's similar, but it's a little bit different. Take a look. Let me try and explain this in the best possible way, and then you guys can pay attention.
So should I not draw this then?
You don't necessarily have to draw anything.
Oh.
Look, the drawing of a stadium uses a scale of 3 inches. Every 3 inches is 200 feet.
Oh, it's already gave us the thing.
Find the width of the stadium if the width of the drawing is 12 inches. Well, what do? Well, you figure out, first you do 12 divided by 3 is 4. So it's 4 times this, right? So if it's 4 times this, I just multiply that by 200. It's 4 times 200 equals 800 feet. Does that make sense to you guys? It's like if I said to you every 1 inch was 100 feet, how much is 4 inches? Well, you'd multiply by 4, it'd be 400 feet, right? So I say every 3 inches is 200 feet. So you divide, okay, your drawing is 12 inches, so you do 12 divided by 3 is 4. And then you multiply that number by the amount of feet. Does that make sense?
Yeah.
Another way to put this is like this. I want you to look at this, because I want to teach you in a different way in case it's easier for you. Another way to put it is, look, you see this ratio? It's the drawing over actual. So the drawing is on top, so that's 3. The drawing is on top, and the actual is on bottom. You see? And that has to equal the drawing over the actual for everything. That ratio is always the same. So the drawing, in this case, they say is 12 inches, and it says find the width of the stadium. That's the actual, so we'll call that X. Does that make sense to you guys? So the drawing over the actual is what this ratio is showing. 3 over 200 equals, well, the drawing is 12 and the actual is x. Does that make sense? And so all I have to do there is cross multiply. And I get 3x equals 12 times 200. Or 3x equals 12 times 200 is 2400.
Could you have done 12 times both sides?
No, because you're cross multiplying.
So then could you do 12 times 200 and divide that by 3?
Yeah, that's exactly what I'm doing.
Oh.
And then you divide by 3. 2400 over 3 is 800. So that's 800 feet.
So we can or we can't do it that way?
You can do it that way. And I actually recommend you doing it this way.
Will we
So you
use
set up
calculators on the
The drawing over, I'm not 100% sure yet. The drawing over the actual equals the drawing over the actual. Does that make sense? That's how you set it up. Whenever you're given this ratio like this, you do the drawing over the actual equals the drawing over the actual. Yeah?
But so how come we don't do the times both sides like we did with the other ones?
Because your variable is in the bottom.
Oh, okay.
Whenever your variable is in the bottom, you have to cross multiply. Does that make sense? So drawing, whenever you're given a problem like this, you do the drawing over the actual. Any questions on that?
Yeah, sir.
Okay. All right. We are.
Is it Kahoot time?
Okay. I want it to be.
But we don't have
I want it to be, but we don't have enough time.
no.
We went over it through the whole time.
Okay. Let's do the Kahoot because I think that's enough for now, right?
Yes.
Okay. So let's do our Kahoot.
Do we still have
What was that? We're gonna have a daily quiz too. We have a daily quiz as always. But I'm gonna change it so nobody go into it yet. I'm gonna change it so I'm gonna take one of the questions out. Actually, I'm gonna take 2 of the questions out. So it's only gonna be 3.
Oh, sweet. Okay.
Very sweet.
There's only 3 questions.
The battery's low.
Oh no.
Guess you can't Kahoot. What that means?
Okay.
Don't get jealous. I know.
Randy, do you have that?
Who's
Is that a real $20
396?
bill?
Oh yeah.
Oh, that was
Eight.
What is that in there for?
Just like just in case.
Just in case you need some money. That's actually a pretty great idea.
Yeah.
So you have money in the back of your pancakes?
Every
Well,
week.
if
it
so,
changes.
Oh, I do that. I do that too. Like,
what if someone takes your phone then, or you like lose?
No.
That means you lose your phone.
no, but you don't lose. You don't. You
That ain't
don't lose your phone.
They're gonna want to steal your if there's $20 in it, they're gonna want to steal your phone more.
Yeah, so you don't put your phone down. Then you keep your phone at every.
Kahoots. Dot.
Or you
I'm
could like
going
put
in now.
Are you serious? I can't with you, Mike. I'm not dealing with you. I can't. I physically can't do this.
Do you answer the mic too?
kind of like.
Are you getting used to it?
Are you guys in?
Yeah, 1, 2, 3. No, there's more than 5.
Who's not in?
Great.
Are you getting in there, Sam?
And
Yeah.
you're getting last one. There we go.
Mike.
And then,
Who's 3960861? That's the real question.
obviously, Mike.
No.
Find the height of the dinosaur.
Ooh, pretty darn tall.
Okay.
That's a Tyrannosaurus.
First off, you gotta convert to inches, right? So 5 feet is 60 inches, so this is 60 plus 6 or 66 inches. 4 feet is 48 inches. 40 feet is 480 inches. And this is my height. I'm trying to solve it. Right? So here's
Wait, you converted it for us?
the red. Yeah, here's the red. Here's the red.
Do you have a calculator?
Here's the blue. Here's the blue. Okay? So all you gotta do is just do that quick division.
Chile.
Set up the ratio and do the division.
I will get this right for Chile.
Wait, the division, you mean the cross multiplication?
All right, so we do.
Or, yeah, solve it.
It's 15.
I don't know about
Oh, shh.
that. What does that say? 480.
So it's h over 66 and then 480
480 divided
Yes,
by
exactly.
48, and then divide that. What?
No,
And then times that by 12, or divide it by 12.
divided.
55.
Marcus, you gotta set up the ratio. You're gonna need a piece of paper. You want something.
So, oh, mine's wrong then.
Just do it. Just do it. God gave you that answer. And then that's the answer.
I hope I'm right.
Oh my gosh, we're gonna tell him.
I think I'm right.
It says feet, it says inches.
Okay, look. You do H over 66 equals 480 over 48. So H equals 480 over 48 is 10.
55 inches.
So I multiply by 66.
Oh, it's feet, not inches. That's why.
Shh, guys, I'm not just trying to talk to myself. Okay? H over 66 equals 480 over 48. 480 over 48 is 10. I multiply both sides by 66. I get 660. In order to get it in terms of feet, I divide that by 12 and I get 55 feet. Does that make sense?
That's flaw. How come you put inches instead of feet? That I got it right, but I put inches instead.
Oh, I got kicked out. Wait, what's the pin again? Who has the pin?
It's 3960.
396861.
It's cheap.
Oh, who's in first?
Oh, great. That's
Yeah.
I remember that show.
All right, look. The scale on this blueprint is 1 inch to 5 feet. So 1 inch to 5 feet. AB on the blueprint is 2 inches long. So this is 2 inches from here to here.
Oh my gosh! I
Find
did
the
it again.
actual length of AB. If it's 1 inch for every 5 feet, and AB is 2 inches, then how long is it in real life?
My phone's at 28.
Wait, what?
Why is all your junk dead?
I don't know.
I think I got this right.
That's easy.
Okay.
Watch, we're all gonna get it wrong just because you said that.
So look.
What is it?
So it's drawing over actual. So 1 over 5 equals drawing over actual. Right? 2 over x. I'm looking for the actual. I cross multiply. I get 1 times x, or x equals 10. 10 feet.
What is that?
I knew I was 10, but I accidentally
Hey.
put that in.
Yeah.
That was a weird scream. I can't do it. So,
I don't have any points.
I'm in second.
Okay. All right. There's no picture for this one. A room is 40 feet long and 20 feet wide. So it's 40 feet long and 20 feet wide.
Okay.
A drawing of the classroom is 4 inches long. How wide is it? So this is 4 inches. How wide is it?
So then we put the X.
So you guys have to be able to come up with these
Yeah, like-
drawings on your site.
Marcy, get out of the way.
The right
Get out of the way.
side.
Marcus.
Wait, that's
You're in
the
4.
room.
Oh my bad. That's 4 inches, right?
Yeah.
I don't know.
All right, so you times that by 12,
So look,
and you get
guys.
30. I don't think that's right.
What do?
No, it's 48.
Mental math.
Red over blue equals red over blue. So x over 20 equals 4 over 40. Right? I multiply both sides by 20. Shh. I get x equals 4 times 20 is 80 over 40 equals 2.
I put 2 feet.
2 feet
So
or
how many-
inches?
How long? What do you think?
Why can't look? You see,
It's the drawing.
You have to use 2 fingers.
this is why I hate.
It's the drawing.
I'm in third place.
You have to use 2 fingers like this.
Okay.
I still have
All right. You guys aren't gonna know how to do the rest of them.
I got this.
Got it. Yes.
let's
Wait, what?
I didn't answer.
Oh, he's doing this.
I just guessed.
Yeah, boy,
Wait,
second place.
why is this time going out?
Let's go.
What?
Who's
No, no, I'm just skipping.
Number one.
You guys don't- All right, you guys start your quiz. You have 3 minutes. Start it.
Who got a 4 or 5?
What? You can start it and save it for later. Start it and save it for later.
Alright, so if Sam